Okay, welcome everybody. This is a panel about voice cryptography. I've assembled at the table here a few people that have done a lot of work in voice cryptography, meaning the encryption of voice, of spoken voice, doing to telephone calls and doing to voice conversation what programs like PGP have done to email, which is making sure we can encrypt it and keep a secret a secret. Let me introduce these people. On the other side is Phil Zimmerman. I think everybody knows Phil. He's the author of PGP. Volker Ernst. He's been working on a project called Harmless Little Box, and he's now working on another voice crypto project. Eric Blossom of Starium Incorporated in California. And myself, I'm Rob Gongrijp. You all know me probably. And I'm also involved in the same company that Volker's involved in, and we're doing a little voice cryptography project of our own. Now, I suggest we all talk a little bit about what we've been doing so far and what we've learned from these projects. So I would ask each of us to maybe use 5 to 10 minutes to speak about PGP phone, Starium, Harmless Little, and sort of describe the project and why not everybody's using it now.
Well, I did a project in 1995 called PGP Phone, and the only resemblance that it had to PGP was the use of the name PGP. Because it's a different problem, it requires a different solution. It's to encrypt a continuous stream of voice is not the same as encrypting a file, or an email message. Instead, you set up a link encryption, which means that you typically do a Diffie-Hellman exchange to set up a session key, and then you encrypt all the bytes that go through the channel with that session key. At the end of the call, the session key is destroyed, the Diffie-Hellman parameters are destroyed, so that nobody can figure out later what was in the call by if they were to pull all the bits out of your computer after the call is completed, they would still have not enough information to reconstruct the call, even if they had intercepted every bit of the call. Well, PGP Phone was part of the intellectual property that I handed over to my own company when I started PGP Inc. in 1996. The company was not interested in PGP Phone. They were only interested in PGP. But because I was chairman of the company, I was able to get them to do whatever I wanted them to do. And so I made them complete the product into a product with a manual and, a shippable product and sell it. But I just could not sustain the interest of the marketing and salespeople who were really focused on the flagship product, the email encryption product, PGP. And so it withered away. It became an orphan product. Later on, when the company was sold to Network Associates was even less interested in PGP Phone than PGP Inc. was. That is to say, not at all. And in fact, later on, I tried to get the product back from them on the grounds that they weren't going to do anything with it. But it was difficult to have any discussions with anyone in the company about doing that because no one at Network Associates was even aware of the existence of PGP Phone, and they were certainly not aware that they owned PGP Phone. Gee, I wonder what I could have done with that. And so it was difficult to get anybody to have a meeting about it. Everybody was busy trying to do the business of the company, and nobody wanted to devote any management bandwidth to negotiating selling the product back to me. So I gave up in frustration and decided to re-implement it again from scratch, this time in Java. So it's pretty much the same project with the same protocol. There's some minor differences in the protocol because of the passage of time. 5 years is enough time to think of a few other ideas to add to it. Now it uses AES, but it still has basically the same protocol. So far, we've implemented the telephony part of it, which works fairly well. But we're just now adding the encryption, which is much easier than the telephony part. The telephony part is where all the really, I mean, if you're a cryptographer, the telephony part looks hard. And so, you know, trying to get everything to work with low latency is not that easy to do with PCs talking through the internet. Now, the original product was not conceived of as a IP telephony product. It was really just a way of having your computer talk to someone else's computer through a modem. So the two computers would use the phone system between them, connected with two modems, and the internet was not involved at all. So the latency wasn't that bad. There wasn't any network congestion because there was no internet in between. And you know, it had nothing to do with saving money on telephone calls. A lot of the IP telephony products are, the purpose of these products is to let you make cheap phone calls. Well, this has got nothing to do with cheap phone calls. It's to have a private conversation. I mean, if two lawyers who each make $300 an hour want to have a private conversation about their case, who cares about 10 cents a minute or 7 cents a minute or whatever? It's just not worth saving a few pennies to have a secure phone call. So the first product didn't use the internet. So people looked at this was back in 1995, they looked at this and said, why don't you add the capability of sending this stream of bytes over the internet? So I said, okay, so we added, as an afterthought, an internet layer below it and sent it through the internet. And then it turned it into an IP telephony product. That was the kiss of death as far as the marketing of it was concerned. Because from that moment on, I couldn't convince my marketing and salespeople that it was anything but an internet telephony product. Oh, with encryption, by the way. It's the other way around. It's an encrypted voice product, which, by the way, works over the internet. But they just couldn't see it that way. So they saw it as competing with the other IP telephony products, which were created by companies whose entire companies were focused on the problem of IP telephony. So they said, we have no hope of competing with them. So I really should never have made it work on the internet. If I hadn't, then it probably would be a product today. But anyway, so the new product, we're coming at it from the other direction. We're doing IP telephony first because today it's actually a little easier to do it that way. Maybe later on we'll add the capability of going through a modem like we did in the old days. I don't program anymore. I haven't written code in many years. And so I've had to get other people to do the job of programming for this. And I need help because since the NASDAQ downturn, it's been real tough to get funding for this project. So if any of you out there are Java programmers and you want to help on this project, please see me after this panel, because I need volunteer help. I do plan to publish the source code, so, you know, for peer review and all that. I guess we should just pass it on here and then we can get into questions later.
Okay. Well, my background is a bit the harmless little board, which I made together with Hako, and a few other people were working there too. This is a standalone speech encryption device in the sense that our idea was to keep things very simple, not using complex operating system, unknown hardware, and all this kind of things. So we basically put together a 32-bit RISC CPU running at about 100 megahertz, a bit of RAM, an AD converter, and a phone line emulation so that you can connect your standard analog telephone set and it emulates the line. And on the other side, it's got a serial port where you can connect a Haze-compatible modem or anything else that provides this command set. Yeah, so this was basically an approach to make everything yourself, keep things very simple so that you can ensure security. We got it running some way. The platform runs, the hardware runs. You can even run Linux on it. It's got an SH3 CPU made from Hitachi. That's quite nice. But we didn't do too much on the software. We got a bootloader, we can run C programs, all that stuff, but we didn't go too much into the crypto part, mainly because it's all a lot of work and even getting the hardware done. I mean, we built our own PCBs. Haku is quite good at this, and well, you have to solder in chips with about 200 pins and stuff like this. It's not really so easy to get all this working, but well, it did work. And we also had speech compression, which is the most, which needs most of the CPU running there in real time, so the CPU is fast enough. So basically, we built a platform and played around with it, and it's quite nice for cryptography. And well, the approach with this thing is really to keep things very simple. So we didn't do anything like IP or whatever, because this would have involved using at least a real-time kernel and thereby exploding the lines of source code about the factor of 10, because, well, if you just do it over a Hayes modem, it's not too much code. At least you can verify it a bit. So, well, that was the background for me for the last few years. Even I didn't do this as a job. It was a hobby project. Well, now it's turned a bit into a job, but it's not the HLB we are doing anymore, even though this is my background. We got a new project together with Rob. He'll probably tell you a bit about this. Well, so this is the background with the HLB, which is still available. The approach was that everybody can build it for free as long as you want it as a private thing and don't make money with it. You can download the source, it's all on the internet, and build the PCB. Everything is there, and it will run and say hello world to you on the serial port, and you can do whatever you like. I mean, it's got the phone line on the one side, the serial port on the other. It's also got 4 to 4 rows keyboard matrix, a little LCD, 2 lines, 16 chars, something like this. So it's basically a small platform to play with. But at the moment, we don't really do active development on this, even though the hardware is stable. No?
Thanks.
My name's Eric Blossom.
Much closer.
My name's Eric Blossom, and I got started in the voice cryptography arena in 1993 when, as you may recall, AT&T, in cooperation with the National Security Agency and the FBI, introduced this secure phone that the first thing it did was transmit the keys to law enforcement just in case they ever needed them. I kind of thought that was like, gee, why don't you just take your house keys down to the police station and leave them there just in case they need them sometime. I got introduced to a bunch of people back then. I said, wow, I think I could probably build a product around this. How hard could it be? Well, it turns out it's quite difficult. Meanwhile, years later, we've been through a couple different companies with it, and most recently, we put a company together named Starium. And Starium has got beta units built of, this is a device that hooks between the handset of a wired telephone and the base. Works with ISDN phones, analog phones, most PBX phones, and allows you to create a completely secure communication between pretty much any place in the world, as long as you've got one of these units or an equivalent unit on the other end. The basic technology in here is digitize the speech, compress it down to a data rate that we can get through a V32-bit modem that's actually built into here, and then shove it across. We set up a session key for each call using Diffie-Hellman with a 2K-bit modulus, and then use either triple DES or AES to encrypt the traffic. So anyhow, this was a little different approach than the harmless little box. We really went with, okay, what can we build? How can we make it look good? Can we have it be simple and easy to use? The idea was, for example, if my mother couldn't use this thing, we're not winning. So we went with a minimum number of buttons, hook this thing up to your phone. Ideally, you press one button to go secure and one button to go clear, and that's the end of the game. What we've discovered since then is I served as the CTO of Starium for about 3 years. Since then, I have left Starium. I'm currently working with them as an advisor, but I'm now pursuing some interest in the wireless arena that I'll be talking about this afternoon on GNU Radio at 15:30. But anyway, Starium is available. There are beta units. There's a website, www.starium.com, where you can find information and contact info. If anybody would like to talk to me about this afterwards, please track me down and we'll compare notes. Thank you.
Okay. Hang on one second. As some of you may know that have been to the SEM's secure SMS workshop yesterday, I've started a new company with some other people. It's called NAH6, and NAH6 is building secure SMS applications for all kinds of handheld and palm-based devices. And we're also building a secure voice application for high-powered organizer phones. And we're presently looking at the Nokia 9210, which is this nice flip-open organizer phone, to put voice cryptography inside the actual organizer part of this, where the application would, again, very familiar to all of these things. It would set up a key using Diffie-Hellman, a session key for that call, make the call to the other side using the GSM data call as if it was just using the phone as a modem, and compressing the voice and encrypting it and sticking it on that channel. The nice thing about our project would be that it's both the source would be available and the program would be free for non-commercial use, and you could just download it on your own commercially available device and have secure voice. At this time, it's maybe nice to explain a little bit how this Diffie-Hellman thing works, because the four of us have been talking about it. What basically happens, I don't know if everybody's familiar with the Diffie-Hellman scheme, but what basically happens is two parties can sit together and throw up some random bits in this magic machine called the Diffie-Hellman key exchange algorithm. They throw some random bits into that, and if the outside party doesn't know both these random piles of bits that have went in, they can't come up with the secret that the two of you then at the end of that know. So without any prior key exchange or any prior setup through some other channel, two people can set up a secure secret that they can keep from the outside world. The only disadvantage or the only danger is an attack called the man in the middle, where your favorite intelligence agency or whoever would have two of these devices and stick them back to back, and then you would be talking to the one side of them and be doing this key exchange, and the other side would be talking to the other side of them and doing the key exchange. And then, of course, if you stick the audio back to back, there would be a channel. How you get around that is you display a shortened version of that secret, a hash or some version of that secret on the screen, and have the party read it to each other. And if you know each other's voice, it becomes very hard for an adversary to foil that, because they can never arrange to have the same secret negotiated with both parties. So that's how that works. That's how you can have a secure phone call without a huge public key infrastructure, just by knowing the other person's voice. And of course, the NSA could have a room full of impersonators sitting there ready, waiting for me to say this number, and then interrupt this link, say the other number. But that would, if we can force the world's intelligence agencies to go through a theater like that, we're happy. You have to remember also that the voice cryptography thing is very much about making it harder for them to tap your phone than it is to tap your room. Because there's no point in making it much harder than tapping your room. Think about it. Right now, we're seeing phone traffic being tapped widely. We're seeing traffic tapped in the hundreds of thousands of channels simultaneously. So that's what we're trying to foil here, is the sort of massive tapping of phone calls. If you are paranoid enough to worry about really direct attacks, then any of this is probably not good enough. If you have military-style worries about your communications, then there's many other things to worry about. Like, this device is beautiful, this device too, but they have nothing called red and black separation, meaning the clear voice goes over the same circuitry that's also involved in the communications part of it. So for instance, for all I know, what I talk into this microphone may well be modulated on the GSM channel, because the amplifier that does my voice is somehow connected to the amplifier that does the RF part. But these would be very, very involved attacks that would be very hard to play against. You have to guard against them as much as you can, but they would be very hard to play on all of us. This device can probably be heard loud and clear if you're within a few hundred meters and are willing to go for the electronic emissions that come from it. But again, that would take like thousands and hundreds of thousands of trucks with equipment to roam our cities. We would need bigger roads. So anything that would basically foil the vacuum cleaner style attack in our minds would be really helpful. Anything else? Yes, I think we should also discuss a little bit the other things which aren't here. The approach we've done with this phone is not unique in the sense that Siemens of Germany thought of it also and has built a phone which does encryption.
Unspecified, no documentation, 128-bit, it's great, but I mean, there's a fundamental issue with any of this cryptography business is how do you know if it's any good? And I just don't, at least if they tell me what they're doing, I have half a chance of believing they know what they're doing. So, I mean, I don't know. Siemens is quite competent. The people who are promoting that phone is Roland Schwartz, who also built intercept gear for the European intelligence agencies. I mean, what could possibly be wrong with it? Do you want to take questions?
Yeah, let's wait a little bit. There's a few other things. The U.S. military has a device called the STU-3, which is the secure telephony unit, and it's very much a unit that goes by a large public key infrastructure, which is managed by the National Security Agency. The National Security Agency, in that whole system of defense contractors and military personnel, does not only serve as the certificating agency, but they also actually have the secret keys.
Yeah, not sure about that, Keith.
I think they do. At least for all of the lower level, they actually distribute the secrets. So there's a large network of secure telephony going on in the U.S. military. There's a few other products out there. There's Nautilus, which only does modem to modem between PCs. It's I'm not sure.
The funny thing about Nautilus is that the first time I started on the secure phone project, it was actually earlier than 95. 95 was when we came out with PGP phone, but a couple years before that I started on Nautilus. And we wanted to call it Nautilus because it was like, the submarine in 20,000 Leagues Under the Sea. It sank clippers. And I was working on it with a guy named Bill Dorsey, who we were working together on this project. But then just as we were starting to get cranked up on getting it to, to work, the criminal investigation started for me. And that just completely knocked me off of that project. And I left Bill Dorsey high and dry on that. I've always felt guilty about that. In fact, I would like to run into him again so I could apologize to him again for that. But he went ahead and developed the project himself. And then 3 years later, when the criminal investigation ended, I had gotten back into getting PGP phone out, and that sort of competed with Nautilus. So it was kind of a double whammy there that I did on him. It's too bad. It was a good name.
Yeah, and then there's another thing called Speak Freely, which is a project by a guy named John Walker. I think he lives in Switzerland. And he's built this Speak Freely as a pure IP phone. It only does internet. And it can use a variety of encryption algorithms and a variety of compression algorithms. And it's something you could play with. It's a really nice and usable crypto telephone for internet use. Now you have a complete overview of everything that happens in crypto telephony. Let's ask some people here. Presently, nothing interoperates. We've just been talking to Phil, and we're going to be talking some more this afternoon to see if we can make what we're doing possibly interoperate with what they're doing. But the thing is, the lower level protocol, very much the the characteristics of the lowest level protocol that runs on the link layer on either the GSM phones or the internet or
Yeah,
you're,
at
you're
the
trying
lowest
to jam
layer.
quite a few bits in a small channel.
Yeah, no, everyone here is in favor of interoperability. Now, the question is there's some reality-based problems that kind of rear their ugly heads. And part of the problem is that some of these devices are targeted at different communications media. So if you look at the cell phone stuff today, what you got available is a 9600 bit per second channel. We basically assume that also for the wired. The IP telephony's got a bigger channel. There's some low-level framing differences. I mean, one thing that might be a step in the right direction is getting all of the high-level stuff to agree, and then just have the low-level framing be different. But ultimately, everyone that I've talked to, including commercial competitors of Starium, who are in general open to the idea of interoperability, in that, you know, the last thing we need is yet another non-interoperable secure telephony solution. You know, we need more of these deployed. They need to be easier to use, and, you know, last thing you need is, you know, the VHS versus Betamax problem.
Yeah.
We can't hear you here.
We've got a
Let's pass
mic
this
up
microphone
there.
around, yeah. All right.
What's been the development of the self-synchronizing streaming ciphers recently? I mean, I basically can count them on one hand. Is there any new ones that anybody's heard of besides triple des or anything like that? I mean, I know block ciphers are, you know, dime a dozen, but I haven't seen many, you know, stuff that you can run, you know, streaming media across securely recently. Any new ones?
Well, in the case of,
Can you repeat? I'm not sure I got the question.
he wants to know what stream ciphers are available. What are we doing for stream ciphers? Both Eric and I are running a block cipher in counter mode, which is a way of turning a block cipher into a stream cipher. Now, when you're running over a modem like Eric does, running a stream cipher makes a lot of sense. But when you're running over the internet, you could either run a block cipher or a stream cipher, because the packets that might arrive in a different order, they're never going to arrive in a different order through a modem, but they might arrive in a different order through the internet. And so the way you synchronize things is different. Now, I decided to run a stream cipher anyway, even though it is over the internet, because the original PGP phone was originally supposed to run just modem to modem, just like his stuff. But we have a slightly different approach to this, to counter mode. I use a structured counter, and he uses a homogeneous counter. And whatever you want to add to that.
No, I mean, there's plenty. The crypto in these products is really generally not the problem. It's all the telephony-related engineering. So, plenty of ciphers available. Looks like AES is the default that people will use at this point, and then it's a question of, you know, how do I minimize my overhead and be able to get my bits across. So, and we use streaming ciphers, again, just as a sort of technical detail, that we're assuming we're running on a relatively noisy channel, and what we're interested in is being able to talk even if the speech quality isn't perfect. So it's a little different than sort of your standard SSH connection where, gee, I want to make sure that my bits get there and that they're correct. I'd rather have my bits be there and somewhat messed up as long as I can still hear the person. So. Sure. Okay. In our overhead is asymptotically zero, because basically once we establish synchronization, we transmit nothing but the raw bits. So there's no start or stop bits. There's no framing bits. There's 1 bit per frame that winks off and on and off, 1 0 1 0 1 0, and we get hints from the vocoder decoder that says, yeah, this is starting to look not like speech, or if this winking bit stops winking, we know we've lost synchronization. But what we've noticed is that pretty much on every wired phone, once you've established sync, unless you have like a caller ID or call waiting, some kind of tone interrupting, pretty much there's no change. You may have bit errors, but generally you won't actually lose a bit. You won't lose timing, and as long as you don't lose timing, nobody cares. And then if you do lose timing, it's 2 round trips to reestablish, which is, you know, under 100 milliseconds typically.
Yeah, when we started our project, the first thing we did was cipher feedback mode, which means that a single bit error on the modem would mess up a whole cipher block. Actually, a whole cipher block plus one bit of another cipher block. And this would produce a lot of damage from small errors. And we eventually switched to counter mode, which made it so that if a single bit error happened, there would only be a single bit error at the other end. That's a better way to do it. Now, when you go to the internet, it doesn't matter because the internet either delivers the whole packet intact or it doesn't deliver it at all. So we could have used cipher feedback or any of the block cipher modes.
Any other questions?
Yeah, there we are.
Okay, the question is, what's the pricings of such systems? I can talk a little bit about the Starium thing. There are beta units available today. I don't know exactly, because I'm no longer directly involved. You should send email to info@starium.com, and they'll get back to you and let you know. I know that the idea was that these would be cheaper than any of the other commercial. I mean, people have tried pricing these things at different places, and historically they've been, $3,000 US. That we were at one time looking at pricing in the $700 or $800 US, but it appears that really to get any kind of volume, you really need to get the price down lower. And of course, people argue, well, there's certain people who will pay a lot. Well, yes, there are, but how many of them are there, and how hard is it to find them? So, in trying to build a business, I'd rather be selling to people who want them than trying to, work overtime to find where's that customer that will pay me, $7,000 for 2 units. So. Yeah. Paul, can we get a mic to this person?
He's been to your
Just
website.
yell real loud.
Pass the microphone to him. Man.
Hi. I just went to the product website, and there's no product information whatsoever anywhere on the site.
Right.
And the contact information, well, maybe, but the news section also doesn't say anything about it. And usually when I see a company in this situation, they wouldn't talk to me anyway.
Why don't you send email?
I'll
and
send
tell
an
them,
email,
I mean,
okay.
here's the thing. They're not ready to announce a product. I mean, you can come look at this thing afterwards, get your hands on it.
Can I buy it from you?
Uh,
By the way, is it open source? Can I see the code running on
okay,
it?
it's not an open source product in that there.
Can you trust a not open source product, which is involved in cryptography? Would you trust a product that crypts your messages and is not open source?
Yes, there's conditions in when I could do that. Let's say that it wasn't open source, but I was allowed to review the source code under a non-disclosure
Yeah.
agreement. I was able to build from
Can we do
source
that?
using their tools.
Okay.
Okay.
And can we?
Yeah. There is a plan. There is a plan to solve this problem because we think it's where there'd be third-party review of the code. Now, given the amount of money that went into building this thing, we don't see how we can give the code away and make any money. And we understand the desire to see that you are confident that the crypto does what it says it does. So,
Okay, thank you.
yeah.
I can maybe talk a little bit about the pricing for the product that we have in mind. We're still developing, but we're planning to release free for non-commercial use, as I said. We're hoping to make money through selling commercial licenses and adding things like authentication based on maybe the SEMS key or maybe other public keys that we do. So that's how we plan to make our money. We're hoping to keep it free for everybody, and at least the source is going to be available. What's with the source of this Java thing? It's also going to be completely open?
Well, originally I was trying to get funding from another company that was going to, back the project. I mean, I have to put food on the table and pay the rent, so they were going to allow the source code to be published, but they weren't just going to give the whole product away. They wanted to charge money for it. But that funding dried up when the stock of the company that was going to fund it went from like $17 to 78 cents. So
Oops.
I don't know how, I mean, I'm trying to find somebody else to fund the project. And so until I figure out whether or not I'm going to get commercial funding from another source, it's not clear to me what exactly the intellectual property status is going to be. I mean, I can certainly make every effort to make sure that the source code is visible, in the same way that PGP source code used to be visible, in that its intellectual property was encumbered, but it was still available for peer review. Beyond that, I don't know what the intellectual property status will be. If it turns out that I can't get funding from anywhere, then I don't know, maybe I'll just open the source it, because maybe I'll give up and open source it. But if I do that, it also means that I can't work on it very much because there won't be any money to pay for it.
Wait for the microphone there.
Looking at the mobile phone solution, if we look at, say, the G3 phones, which are of course all going to have IP connection as well, is there any plan to have IP telephony, secure IP telephony from a G3 phone?
From a what phone?
What did he say?
It's like the third generation. It's like ones are IP6 and all the rest of the crap that goes on them.
It would be relatively easy to do, except there isn't any G3 phones yet. And last time I checked, the
Except
G3
in Japan.
phone, the G3 phone occupied 2 racks in a van. So, as soon as these are out, of course, somebody will think of this. The present strategy of the people that manufacture the phones is to serve the interests of the people that have to operate the networks that these phones are on. And these people's interests are very obviously to have tight control over the voice channel. If you look at how GSM is designed, it's designed so that the voice packets can only go to your provider. You do not have access to the voice compression algorithms inside that phone. The entire network is built so that only the provider can provide voice services on it. The data call is specifically engineered to make sure that it has all the properties wrong for any kind of real-time delivery of packets. This is all done on purpose, and it's all done because they make their money on long-distance charges. They make their money on selling you the streaming voice service, basically. So there's this continuous problem, and I don't think it's going to change with the arrival of G3 phones. There's the continuous problem that you have to buy this technology from people that make their money from selling you the streams.
Yeah, I mean, it's also going to be possible, perhaps, with the GPRS, but this is the fundamental issue, as far as I can tell, is, as Rob said, that the operators do not want to get turned into bit pipes. I mean, if they turn into bit pipes, you're now in the ISP universe where, oh my, that looked exciting for a while, but now it's not exactly the best business to be in. So we see that in the United States, although some of our phones now, there's able to get data to the phones. It's usually in some kind of a walled garden. You really just, even though the phone technically will do IP, it just doesn't go anywhere.
There's there's phones in the US that actually do IP on the air. So you got a full IP stack in your phone, and if you want to get on the internet, you actually end up doing IP and then some kind of telnet over IP to a modem at the ISP, so you can call the modem at the cellular provider, so you can call the modem at your ISP and build a PPP connection on top of that. And all of this is because of billing. They could just give you the raw IP from the phone straight off. The entire business model for UMTS is built on we provide the new mobile internet, and therefore people are going to buy their shoes with us. Because it basically, for UMTS to ever make money, it takes us, each one of us, to triple our spending on mobile use in a world where prices for communication are going down. So it's interesting what the future is going to bring.
What do you think are some of the reasons it's difficult to get the general public interested in secure telephony?
The question is, let's just repeat the question, was how come the general public, this is a paraphrase, how come the general public isn't all that interested in secure telephony? Is it close enough? Mostly speaking from a U.S. point of view, I think mostly people say, well, what have I got to hide? Or it's kind of a, you know, I'm just ordering groceries or something. It seems to be the general mentality. In the States, there don't appear to be many gross violations of the intercept law. Now, this doesn't mean that they aren't happening, but it could be the difference between a law enforcement point of view and an intelligence gathering point of view. Customers that we've talked to in Central and South America have a completely different point of view, and they actually assume that everything's broken and want to do something about it.
Yeah, the fact that the American public is, in theory at least, shielded from the NSA legally, probably, you know, creates a sense of complacency.
Yeah, I think the U.S. firms I've talked to have this strong feeling that, well, what do we care? The NSA is on our side anyway. Whereas European firms at least have the feeling they have a little more to fear. So there is larger business interest in Europe and probably in Asia than there is in the U.S. As far as the general population goes, it's really hard to convince people that to encrypt their email is a good idea, or to there's the general problem of explaining signals intelligence and communications intelligence to people, and explaining how this filter would work. The standard approach is always, well, what would they do with all this information? And explaining how these technologies have been perfected over the past 50 years or 60 years is quite a challenge.
I think another piece related to is that we have not yet succeeded in having voice cryptography be completely transparent. Transparent to the point where you don't know you're making a secure call. Ideally, you would want, and this is possible either in an ISDN environment, which
People, and explaining how